All right, welcome back. Today's topic is parametrics. This is back in chapter one of our calculus book, and in case you're not in my class and wondering what's going on, this isn't part of the AP calculus curriculum, so there's just a few things that I teach after we take the AP test at the beginning of May. All right, let's talk about parametrics. So, what is parametrics? Why do we need it? Well, first of all, if we think about a graph of x versus y, this doesn't necessarily tell us what's happening with respect to time. We can't really see it happening. Um, we could graph the height of, for example, a projectile with respect to time. And when we did, we would see that the projectile went up and then it went back down again. Excuse the jumpiness. I don't know what just happened there. Or we could do a graph of the displacement of the same projectile with respect to time. And what we would see is sort of the same thing, is the projectile would continue to move to the right until such time as it hit the ground and stopped. But we don't see the motion of the parabola just as it goes. So parametrics is going to allow us to do this. So let's take a look at an example. And what we are going to do is we are going to define x as some function of time and y as some other function of time. So for our example, we're going to define x as the square root of time. We're going to define y as time, and we're going to define this for time greater than or equal to 0. So let's jump over to our graphing calculator. If you have your graphing calculator handy, otherwise you might want to pause and grab it. I'm going to show you how to use the Texas Instruments TI-84 because that's the one that I have. I don't know why this is, yes, there we go. So first thing we need to do is put it in parametrics mode. On the TI, we press the mode button. We look down at about line 5, and you'll see function, parametric, polar, and sequential. These are all the kinds of graphing you can do. And we're going to choose parametric. And now what you will see is that when you go to your y equals equation editor, that we've got x1 as a function of t, y1 as a function of t, instead of just y1, y2, y3 working our way down. So let's put in square root of t. Now, one more thing, the X button that if you're familiar with this calculator you've been using, now when we push it in parametric mode, it'll actually put in a T instead of an X. And Y1 is just Y is equal to T. Next thing we need to do is tell it what our time interval is. So we're going to go to Window, and you'll notice that they've added Tmin, Tmax, Tstep. So we're going to go, in this case, t greater than or equal to 0 means we can start at 0, go to infinity. We don't need to. I'll just type in 10 because I don't know how far we need to go, just enough to get to where we need to be. Now t-step is going to be how fast is it going to graph. If you make t-step too large, it's just going to bam, graph. You're not going to see anything happening. If you make it too small, you're going to fall asleep waiting for it to graph. So there's something in there from before, or maybe it's a default. We'll just leave that and see what happens. And finally, we're going to just hit graph. Because I'm using the calculator app, I'm in a standard 10 by 10 window, and I will hit graph, and let's see what happens. Notice that you saw what appears to be a parabola being drawn in real time as we watched it. So let's go back and see if we could turn this into a Cartesian equation. And we know that y is equal to t. We know that x is equal to the square root of t. I'm going to square both sides of the x equation, which means that t is equal to x squared. And substituting, what we see is that y is equal to x squared. And of course, we had defined t as being greater than or equal to 0. But since x is the square root of t, that means that x must be greater than or equal to 0 And notice that that is exactly what we got. We got the parabola y equals x squared for x greater than or equal to 0. All right, so my students, go ahead in the book and do exercise 5. And that was just a quick introduction. We'll be back with some more examples of what we can do with parametric graphing. Thanks for watching.